Hello everybody, this is the quick video notes for week number 6, talking about polygons. So, hopefully you got your notes opened. We're going to look at just 2 of the examples. I'll talk about most of the ideas that you see in your notes. Excuse me. So, look at this is example 1, part B. So what we got in this picture here is basically there's 3 triangles. You got this equilateral because all 3 angles are equal, and you got this second little triangle here. It's an isosceles because of these 2 angles being equal, and they are sharing a side. The third triangle is the whole thing. That's not really the important part. We're going to focus in on these properties of these 2 triangles. So it is an equilateral triangle. All 3 angles are equal, but we're given 1 side length. Now, in an equilateral triangle, all the sides are the same. That's important. Over here, now this is good. We could say 5y minus 4 equals this 3x squared minus 32. That's the length of this side. But that doesn't do us any good because we can't solve an equation when we've got 1 variable and a second variable with only 1 equation. So what we're going to do is kind of ignore this side length for a second. In this triangle here, it's an isosceles triangle because these 2 angles are equal to each other. So that means this side and this side are congruent. Now, this side was also congruent to this side. So what that means is this 5y minus 4 and the y plus 12, they're equal to each other. So that's where we're going to start because that's the same variable. 5y minus 4 equals y, that's a y, plus 12. Alright, subtract y from both sides. You get 4y. Add this 4 to both sides. You get 16, divide both sides by 4. You get a y value of 4. That's super. Now, we still need to solve for x. Okay, this is part of our answer. So, if y is 4, y plus 12, so 4 plus 12 is 16. These 2 sides are the same, so that means this side is 16. So that's what we're going to do, is set this equal to the 16. That's how we're going to solve for x. So, looking at this equation, first thing I'm going to do is add 32 to both sides. So I'm just going to work over here. 3x squared equals 16 plus 32, 48. To solve for x, I'm going to divide both sides by 3, and we get x squared equals, come on pen. Pen's frozen. There we go. X squared equals 48 divided by 3 is 16. Alright, to solve for x, we take the square root of both sides. Whenever you take the square root of both sides in an equation, you get 2 answers, the positive and the negative. Square root of 16 is 4. Now, we always have to check our answers. This is representing a side length. Side lengths have to be positive numbers. So this negative 4 is a little bit of a concern, but when we plug it into this, negative 4, when you square it, is positive. It works out okay. All of this becomes a positive side length. So we actually have 2 good answers for the value of x. All right, that's that problem. Looking down through the notes, this is example 6. So look at all your notes. There's a bunch of different properties that you're going to need. The sum of the angles of any sided polygon, those types of things. All the equations are in the notes. But I wanted to talk about this example because there's a couple of connections we need to make. So you were given that this whole thing is a rectangle. In a rectangle, the diagonals are 2 things. The diagonals are congruent to each other. That's a really useful, as far as construction field is concerned, that's a really useful property. In a rectangle, the diagonals are congruent. But because a rectangle is also a parallelogram, the diagonals bisect each other. So the diagonals are congruent and they bisect each other. That means this side, this, and this are all the same. We're going to need that. Now, it's a rectangle. It's also a parallelogram. So this side is parallel to this side. Okay, where I'm going with this is there's a bunch of ways we can solve this problem, but in order to solve for both x and y, this is the way I want to go. I think this is the easiest way because you're going to have to use this anyways. So these 2 sides are parallel. I'm going to look at this diagonal as a transversal. This angle, the 12x plus 9, is an alternate interior angle up here. So I'm going to switch this 12x plus 9 up to here. Now, these two angles right here, it's a rectangle. That's 90 degrees. So that's where we're going to start. 2x plus 11 plus the 12x plus 9. Those two angles add up to be the right angle of 90 degrees. So, combine some like terms. 14x plus 20 equals 90. I'm going to subtract the 20 from both sides. That gets us 7. I'm going to divide both sides by 14. 7 divided by 14 is 5. Okay, so there's our value of x. That's part of our answer. Now we need to start searching for y. So if x is 5, 12 times 5 is 60 plus 9. This is a 69-degree angle. Back to this. These two sides were the same. Of this triangle, these two sides are the same because of those diagonal properties. That means it's an isosceles triangle. So if this angle is 69, this angle is 69. All three angles of a triangle add up to be 180. So y plus 69 plus another 69 equals 180. Plus 69 plus 69 is 138 equals 180. I'm going to subtract that 138 from both sides. We get y is 42. There's our other value for y. Okay, that's a quick rundown of some of the properties of polygons. Like I said, check your notes. The other formulas are there. The other properties are there. If you have any questions with any of this material, email your teachers and talk to them during office hours. I hope everybody's doing well. We're getting real close to being done for the school year. Take care, everybody.